Alright, so for the previous two parts algorithm with hashing, we have demonstrated it is very useful for implementing many operators. However, we can see for this kind of algorithm, we still need to partition the data of the relation we have into buckets. Actually, in the real world database system, we have a very natural hash function, this kind of mappings, which is called index, right? So therefore, here we will choose this index-based algorithm instead. In other words, we will utilize the index tables available for the relations to utilize them to help us to implement the algorithm for these operators. For this kind of algorithm, we don't require any parse of the whole dataset anymore because we have index table. So given some keys, we can retrieve or fetch this kind of tuples directly with the index tables, right? So in a clustered index, for all the tuples with the same value of the keys, they will be partitioned or clustered as few blocks as possible. In other words, in this way, given a such key, we will retrieve the corresponding tuples as well as blocks directly with these index tables. And we also show you with some numbers with this index-based selection algorithm. Let's say we want to implement a very simple operation. It's called selection, right? So given a relation R, and we want to select the tuples matching our requirements, some attribute equals to value V. And we want to show you how we use this kind of index-based algorithm for implementing this selection. It will be very simple and very straightforward, right? And it actually depends on if this index table we have is clustered or unclustered. Let's assume if we have an index table which is clustered on the attribute A. If so, then the cost for implementing this operation will be about the BR over VRA. I hope you still remember this notation. This BR denotes number of blocks for the relation, and this VRA denotes what? It denotes different unique values we have for the relation on attribute A. So if the index table we have is clustered, in other words, we just need to retrieve the corresponding blocks for storing the attribute with value V directly. It depends on how large or how many blocks we will store them for this kind of tuples, right? However, if the index table we have is unclustered, in other words, we have to go over all the tuples instead of blocks, right? We have to go over all the tuples with the value V instead for the attribute A. So the cost for an unclustered index will be about TR over VRA, right? This TR denotes how many tuples are there for the relation R, which will be slightly different from BR, right? And we'll also show you with example. Let's assume we have a relation R. This BR is 2000. In other words, we have 2,000 different blocks for the relation R, and TR we have is about 100,000, and we have 100,000 different tuples for the relation R. As to the attribute A, in the relation R, it has 20 unique values or different values. And we want to compute the cost of this selection operation with this index-based algorithm. So according to the notation or the formula shown above, if we have a clustered index, if so, then the BR we have is 2000, right? And if this index is clustered, then the cost will be BR over VRA. It will be about 2000 over 20, right? It will be 100. Meanwhile, if this R is unclustered and we have TR equals to 100K, right? And this is unclustered, and the cost will be TR over VRA, right? It will be about 100,000 over 20, which will be about 5,000 as a cost. So you can see, depending on if the index is clustered or unclustered, the cost will be slightly different, right? And also, when this VRA is very small, then this unclustered index will be useless because this cost will be too much. They will be very similar to the TR instead, right? If this VRA is very small. For example, if this VRA is 2 or 1, then this TR divided by this VRA will be about 100,000 like that, right? And this index will be useless. Alright, so this is how to use index-based algorithm for implementing the selection, and we'll show you the cost for implementing operators based on the algorithm.